Very good morning, all of you. Hope you all are doing well. Let's start with today's session. Quick recap of yesterday's session. Yesterday, we discussed about why we need SQL. That is to talk with data, right? I gave examples of different applications, and all these applications are powered by data, right? Then some basic terminologies we saw, like what is data, what is database, and what is database management system, right? So data means known facts of anything which is recorded and kept. And when the data of any particular enterprise, any enterprise in consideration, you're taking any product-based company, you're taking school, you're taking universities, hospital, anyone. So when you're keeping the data of that particular enterprise in a proper organized manner, then it becomes a database. And then database management system. So it's a software, and that software is going to manage your data, going to give facility of creating your database, doing manipulation on that database, providing security for that database. But to talk with database management system, there is only one language, that is SQL, right? Then here I have enlisted some common database management system. In this, some are uh, license based also, like SQL Server, Oracle, they don't come free. MySQL, MongoDB, Postgres, MariaDB, these are all free available. Okay. Some are for cell phone based, like SQLite and all. Some in this are cloud based. There are some cloud based database also, like the Snowflake. A few have not listed also here, right? So few are on cloud based concept also. We have Google Cloud. This is also Cassandra and all. These are some which are cloud based, but they are non relational databases, like MongoDB and all. This is a non relational database. But MySQL, SQL Server, Postgres, these are relational databases. Now we will be discussing about what is relational and non-relational database. That is what our next topic of discussion. And in this whole course, we will be learning MySQL, but it won't be much difficult if you are told to switch to Postgres. This is also quite famous because it's open source, freeware available. MySQL is also open source, free available. So it won't be much difficult if you are switching from MySQL to Postgres. Hardly little bit changes are there. Okay? So common database management I have listed. This Snowflake and all also is becoming famous, but it's also cloud based. Next, we have to discuss about what are different types of database management system. Likewise, there are a lot of big classifications, but a simple classification you can say, like database management system can be categorized one into relational database, okay, relational database management, and another is a non-relational database. Okay. What is the basic difference between them? That first we will understand. And those who are going to work on data engineering, data analysis, and all, they have to work on relational. Major relational database is more powerful, more famous, okay, comparative to non-relational. In case of relational database management, the entire information is kept in the form of tables. Okay, each and every entity is organized in the form of table, and tables are made up of what? Rows and columns. Column will describe that entity. Okay, it will be called as a field or property or an attribute. Like suppose you are storing information of a student, correct? So that column will represent the description about that student. Student roll number, student name, student age, email, phone number, whatever. and rows are representing information about one student. One row represent one student. So this is having little bit mathematical background. Like in mathematics, relation is set of values which are associated with each other. Here also same thing. One row will contain values and that values are related to each other. The name is related to that roll number, the age, the phone. They are all associated. Correct? So one row represent one entity information. Likewise, you can have any number of rows. Okay. So here the information is kept in the form of tables. Tables are organized in form of rows column. Column describe that entity and the rows are information about that entity. And one table and the another table is associated also based on some common column. They might be having some common column, which is generally called as a primary key, foreign key. We'll be discussing about it, don't worry. But they are associated based on some column. There will be one column here, which is associated with some column in the another table. So this way they are related to each other. Correct? Here, the structure of the table is fixed. Structure means only design or schema, we can call it. Okay? We can call it as a schema or you can call it as design. So usually the design doesn't change. Once the design is done, later you'll just keep adding the records. So it will vertically grow. Keep adding the record. So vertically it will keep expanding, not horizontally. Once the design is fixed, you generally don't, you can do modification, but not frequently. Once the design is complete, the table is fixed, you just keep adding the records in it. The structure of the table is fixed. Okay? And generally, when you want to do complex transactions, cross queries are there, like information is going to come from more than one table. Okay, and frequent transactions are going to happen on it. Frequently, the values are getting added, deleted, modified. Then we should generally prefer relational database. Okay, so a best example like e-commerce websites, if you consider, their backend is relational database. Okay, or any ERP system is there of any company where they are keeping everything, their inventory, their employees' information, their products, stock, bills, invoices, everything is maintained. Generally, they go for relational database. Okay? It is naturally suitable for such application where complex queries are there, cross queries are going to happen, information from multiple tables are going to come. You have to join tables and all. Frequent transactions are going to happen. Then we go for relational database. It is well suited. Here, the expansion is vertically, not horizontally. Once the design of the table is fixed, we generally don't modify. You can modify, alter and all commands they are given. But usually in real-time applications, once the designs are fixed, by the developers. Like once the design is complete, that this is one table, these are the column, another table, then the association between them is fixed. After that, we just keep adding the records in it and do operations on it. Okay? Best example is like Oracle. Oracle is a relational database. Then you take SQL Server, you take MySQL, Postgres. These are all relational database. They are called as RDBMS. Okay, so relational database, why? Everything is kept in the form of table and one table and another table is associated based on some column. And generally in mathematics, we call that one row is one relation because in that one row, whatever values are there, they are associated. That student and that student's roll number and that student's email, that student's age, all these are related to each other. Correct? Then comes non-relational database. In case of raw relational database, everything is kept as a document collection. You call it a doc collection. Okay. And in that doc collection, we have any number of documents. Okay. And every document is just made up of key comma value pair. Generally, they use JSON concept. It's called a JavaScript object notation, JSON pattern. Key and the value, key and the value. In that form, it is kept. Okay. So here, each doc is not having any pre-decided structure. Like in one doc, you are having two keys. So next doc can have four keys also. Understanding? Like you have created a doc collection for student. So in one record, just roll number and name is kept. So in the next doc, roll number, name, and email might be kept. So in this case, it can grow horizontally also. Vertically also it will grow as you go on adding the docs. But horizontal, meaning in that case, the structure is not fixed. The design is not fixed. One record can have two keys. Next may have five keys also. So it can grow horizontally also, vertically also. Here it's not. Here, once the design is created, once the table structure is fixed, usually it doesn't change. After that, you just keep adding the records in it and do operation on it. Correct? And therefore, whenever there is a complex query where you have to do joins, that is not well suited over here. Such things cannot be done so easily in case of non-relational database. So generally where you just have to dump the information and present it, like social media websites are there. Generally in case of social media websites and all, or blogs, blog post and all, you do posting of blogs and all, blog title, then you have uh, the author of that blog, some information of the blog. Then in that blog only you are adding some video links and all, your image links and all. So structure of one blog, and the structure of another blog may not be fixed. Correct? So one blog and the next blog is just a document. And in each doc, there is just a collection of key comma value. Not suitable where complex transactions are going to happen, continuous operations are happening, inserting, deleting, updating. For that, it is not suitable. And generally, where cross queries are to be done, where you have to join more than one table, such facilities are not there. Correct? So, MongoDB, you can say, okay, or Firebase, like if some of you have done some cell phone applications and all, so generally this cell phone applications use as a backend Firebase, like the Firebase is there, or MongoDB you consider, Cassandra, and many other which come under NoSQL database. Getting? And always remember if it's a relation, no SQL or no relational database. So if it's a relational database, to talk with that relational database, you have to know one language, that is SQL. So without SQL commands, you cannot talk with relational database. Whereas for non-relational database, there is no such language. There is no standardized language. Getting? Every non-relational database, they give their own libraries, like to add a doc, to get all the list of docs and all. They have given their own commands. There is no standardization for it. But for relational database, there is only one standard language. Let it be Postgres or let it be Oracle or let it be SQL Server or MySQL. Let it be any database management. They have one standard language called SQL. And using SQL only, you can interact with it. Here, they have not made any standard language. Every NoSQL database is having their own instruction set, or they have their own libraries, which you use like the doc dot, then add doc, or get all, which will give the list of all the documents. Correct? So they don't have any standard SQL, or they don't have any standard set of instructions, correct, which is fixed for relational database. Okay. So basic difference I have told you. We will go through it, okay, one by one. First, I told that is relational database. From this picture only, you should know it, how it is. Everything is kept in the form of tabular representation. Getting tabular representation. Column will represent attributes or characteristics, or you can call field. It's called as a field or attribute or a characteristic of any entity of that enterprise. Get it? And one row will represent information about one entity. And then one table and another table is connected. No physical connection. They are having only common column between them. And using that common column, you can achieve cross queries. Okay? And another is a non-relational database. Everything is kept in the form of a document, I said. It is just a collection of document, and every document is a pair of key comma value. So it is not necessary one doc is having two okay, key value. So next doc may have different key values. Understanding? Like here you have stored only roll number and name. Your roll number, name, and email also have stored. Okay? Such thing cannot be done. Here the structure is fixed. The design is fixed. And once the design is done, usually it doesn't change. Once the design is created, after that you just do operations on it. You keep adding the records, deleting, modifying, retrieving. Okay. So uses tables to store data. Correct? Whatever data you have to store, everything is kept in the form of tables. Here, everything is kept in the form of documents. And every document is a key value pair. I don't know whether you have used it or no. Correct? Now, it depends. Now, obviously, when you're learning SQL, so I think you may not have that knowledge. But sometimes, like those who do Android applications and all, so if they are doing cell phone applications, in that many times people prefer using Firebase and all. So in Firebase, everything is kept in this key value. Firebase is a cloud-based database. Here the structure is fixed. Okay, so here you can say everything is in a structured form and predefined schema. Schema means design. So the design of each table is already done. Already you have to tell that this is the name of the table, these are the column, every column data type. So this column integer, this is varchar. Then there are constraints. If you have kept some constraint, everything at the time of design only you have to tell. And once the design is done, now you just keep doing operations on that table. Correct? It is schemaless, no design. They just give you an empty document set. It will just give you one empty doc collection. And in that, you just go on adding doc. And every doc will have its own set of key and values. To interact with these tables, or you can say to interact with relational database, there is one standard language. A standardization is there. And that standard language is this structured query language. Here there is no standard language. Get it? Not only SQL, you can say. Uses no SQL concept. Means they have their own library set, you can say. Library functions are there. And whatever library functions Mongo gives, not necessarily the same will be with Firebase. Correct? And best for complex queries and transactions. As I said, now, where frequently the records are getting added, deleted, updated, okay, retrieved, and you have to connect one table with another. Some values are coming from one table, some from another. That's what we are going to learn in this whole course, how to perform joins and all those things. So that time, best is a relational database. Get it? This is just for dumping the data and presenting it. Like, as I said, no, like in your social media websites or blogging websites are there. So every blog is not going to have a fixed structure. Like in my blog, there can be two videos. In someone's blog, no video, only images are there. Or in my blog, there are 5 paragraphs. Someone else's blog can be only one paragraph. So that blocks don't have any pre-decided structure. They are just stored in the form of key, comma, value. Best examples of relational database are MySQL, Postgres. They both are free, open source. Oracle is not free. SQL Server. That's why, as it's not free, you install pirated versions. MariaDB is just a variant of MySQL. It is actually MySQL. उसका ही एक variant है. There can be many more relational databases. Like a very old, I remember, I have used Sybase. Okay, so that Sybase, Sybac, Sybase was there. Even I have used that Delphi, Ingres, very old now, they have become outdated. DB2 of IBM. IBM is having their own database management. Okay, so they all come under relation. MongoDB you take, Firebase, Cassandra, DynamoDB, Redis. These all come, these are some in this are cloud-based also. They all come under non-relational. Best example, banking system. In case of banking system, structure cannot be runtime change. When the banking system is developed, already each table, their design is fixed. Get it? So in case of banking system, customer information, branch information, then their account details, their transaction detail, the employee detail, everything is fixed. ERP system you take. ERP means complete automation of any product-based company. So their products, their stock, their bills, their invoices, their suppliers, their customers, everything is maintained in that. Getting? So CRM system is there. Okay. Then inventory management. In case of inventory also, the table structures are fixed. Getting? So all they come under which case relational database. Non-relational database, I said like ideal for real-time apps. Now you'll say what are real-time apps? Applications which are connected with some sensors and that sensors are sensing the data and then they're giving it to your application. Get it? Like some applications are there which need the data coming from some sensors. Get it? Different sensors are fitted at different places, and then that sensors are sensing the data and then giving it to that application. So that data cannot have a pre-decided structure. Content management, IoT, Internet of Things, where the devices are connected with the cell phone. So information from that device is coming to your cell phone. It is not necessary of the fixed format. Social media websites, logs. Now, when the logging are done, in every log record, not necessarily the same information is there. Get it? So they all come under non-relational database. So I hope the basic difference between relational and non-relational is clear to you. You can just give me quick confirmation. Generally, cross queries and all, if you have to do cross queries and all, non-relational is not suitable. Getting? When your information is going to come from multiple sources and then you have to join them and create a new report from it, please go for relational database. And both of them are having their pros and cons. Getting? So I said now, where you have to do complex queries, continuous transactions are there, then go for relational database. Getting? Real-time applications, I think you should know. Okay. Example like smart cars are there. Then in some companies there are plants are there. Like if you consider a sugar plant company, sugar factories there. So different pipes are there. So person cannot go to that individual pipe and check for the temperature. So in individual pipes, no, they have set sensors, and that sensor sends the data and give it to some control room. Then the control room will collect that data, and on that it will take the decision and give the appropriate feedback. Again, the feedback. So that time these are called real-time apps. So every time the data which is coming is not of a fixed format. Correct? Then, as I said, content management systems are there. Then Internet of Things, they all go under non-relational. Okay? So the basic difference between relational and non-relational. You can just give me quick confirmation. so that we can proceed further with the next thing, that is what is MySQL, then how to install MySQL, all that things. Obviously, in this course, we are going to learn relational database. Okay? Our focus will be only on this. We have to learn MySQL.
We can proceed with installation.
Okay. ठीक है तो basic difference is clear. This is common difference in interviews. So in interviews you should be clear with your thoughts that non-relational, relational, when to use, when not to use, what pros, what cons, examples, who come under relational, who come under non-relational. Okay, then coming to the next thing, that is why SQL. So as I said, your database management system is having capability of doing everything. It can manage your tables, it can add records in it can delete the records, it can update record, it can retrieve that records and give it to you. It can give security to your database. But all that thing what database management system can do, it will do it only when you instruct to it. Means this DBMS is like your slave. It is saying that I am capable of doing everything on your database. This is your storage. Tables are kept in the storage. So it is saying that I can maintain your tables. Whatever values you give, I will store it. If you tell me to delete, I can delete it. If you tell me to retrieve, I'll retrieve the records and give. So DBMS is capable of doing all the activity. That is maintaining tables, doing manipulations on it, providing security to your database, everything. But DBMS says you have to instruct to me, then only I can do. I cannot do it on my own. So how we people are going to instruct? So obviously we need some medium of communication. We and the DBMS. And the only medium of communication is SQL. Correct? Like between me and you people are attending the session, I am delivering the session, but between us, is there some medium of communication? Yes, that is what? Language. And which language? English. Maybe sometimes Hindi, sometimes Marathi, if you know. Okay, little bit. I'm very much conversant with Gujarati also, Konkani also. So, but all I cannot speak here. So I have taken a standard language, that is English, and sometimes Hindi, sometimes. Okay. But what that language, English or Hindi is it a medium of communication between me and you? And it is a natural language, but SQL doesn't come under natural, it comes under formal language. Okay. Or you can call it as artificial language. But whenever we say any language, does every language give its character set? Does it give its own vocabulary? Does it give its own grammar? Yes or no? Then using that grammar, that character set and the vocabulary, you'll use that vocabulary, you'll use that character set, you'll use the grammar and build sentences. And then that sentences will act as a communication. Will that sentence convey something from one person to another? Whatever sentence is built using that grammar and that vocabulary and that character set, that sentences are delivered from one to another. So it is acting as a information transfer. It is trying to communicate something to someone. Exactly same thing. When the user wants to instruct to the DBMS that please create this table, please take this value and add in this table, or please give me all the records from this table. So how we are going to instruct? So we need some medium of communication, and that is SQL. It's a standardized language. You go for any database management. You go to Oracle, SQL Server, Postgres, MySQL, MariaDB, कोई भी use करो. The communication will be done only using SQL. Correct? Meaning these things are getting hidden now in modern programming and all. Like if you're using Java, Spring Boot, or Python, Django framework and all. So those frameworks are doing the work for you. But still, those frameworks are also using which language? SQL only to talk with DBMS. Getting? So, how the user will instruct to the DBMS with the help of SQL. So, is SQL also going to give its character set? Yes. Will it also have its vocabulary? Yes. Will it also give its grammar? Yes. Grammar means rules, set of rules, isn't it? So, using those grammar rules, right? Sometime you bear this noise. For this grammar rule and this vocabulary, okay, what we'll do, we'll build sentences, that is instructions. And then that instructions will be delivered to DBMS. DBMS will follow the instruction. DBMS will take the instruction, compile the instruction, execute it, do any change in the backend, or maybe retrieve something, and maybe delivering some response back to user. Correct? So in short, SQL is just a medium of communication between the user and the DBMS. Okay? See, so we need a language to interact with DBMS. Okay? How we are going to interact with the DBMS? By using some medium of communication, and that is SQL. Okay, then using this SQL, we will be doing all the CRUD operations. CRUD operations like creating the database, like inserting records, retrieving record, updating records, deleting records. All these things we can do it with the help of this SQL. But DBMS will do this, but we will instruct to the DBMS with the help of SQL. So for doing everything, for inserting, for retrieving, for updating, for deleting, for everything they have provided commands. Okay? Okay. Then moving to what is MySQL. Okay? MySQL is a name of a database management system. Okay? MySQL is not SQL. MySQL will use SQL for doing interaction. MySQL understands SQL commands. MySQL is just the name. MySQL is just a name given to your database management system. जैसे Oracle है, Postgres है, SQL Server है, वैसे MySQL है. ठीक है? तो little bit history about MySQL I'll tell you. Okay, it is developed by one person called Michael Vidanius, and some more were there. Getting some two, three more people, Alan and David, I guess. Two, three more people, but main person, Michael Vidanius. He developed this database management system. And you may say why he gave name mine from his daughter's name. His daughter's name is mine, and then he dedicated that database management system to his daughter, and he gave name to it as little bit funny reason, but that is the only reason. He gave name to his database management system as MySQL. Okay? And it is an open source database. Open source in the sense they have provided along with the source code. It is developed in C, C++ and all. It is coming with the source code itself, guys. Okay? It is coming with the source code. And if you're competent C, C++ coder, you can see that source code and try to develop your new database management. And not only open source, it is freeware. Freeware means no licensing and all. You don't have to purchase it. Just go to their website, download, install, and start using. Get it? Some are there which are not freeware. You have to purchase, take the license and all, like SQL, Microsoft SQL Server or Oracle and all. MySQL is freeware. It is open source, and It's a relational database, means everything is kept in the form of tables over here. That is one specialty. Okay. And now it is being taken over by Oracle. Oracle has taken over, but still it is kept as open source. Okay. So now it is being controlled by Oracle company. Okay. So just short information about MySQL I'm giving. Very sorry guys for this disturbance. There is a work. Just 2 minutes. I just okay. So sorry for that. So MySQL, as I said, it is open source. They're providing with the source code itself. If you download the zip version, you can see the original code what they have done in C. Generally, we don't go for that. We generally download the installer version and install because we are not bothered about it. Our main intention is to learn SQL and start using that SQL in MySQL, right? Therefore, we are not much curious about that, but they give along with the source code. And it is freeware also. Freeware means you just have to download, install, and start using, no license purchasing and all. And it's a relational database. Everything is kept in the table form. Okay. And using this MySQL, we can do activity on the database, create your database, then perform manipulation on it. You can retrieve data, you can insert, update, security, everything is provided. But to talk with MySQL, again, I said you have to interact with MySQL only using SQL. Okay. So MySQL created in 1995 by Michael Vidanius. Michael Vidanius. You have to pronounce it that way only. And later it is acquired by Oracle in 2010. In 2010, Oracle has taken over it. And now it is being marketed by Oracle, but still it is kept as freeware open source product. Okay. Then a little bit history about SQL, how SQL came into in too much detail. I won't go. Okay. Quickly, I'll just try because we have to proceed towards MySQL installation and all those things. This SQL came into existence in around 1970s, and it was a project of IBM people. Okay, IBM they had developed their own database management system called DB2. Okay, DB2 is their own relational database management, and they wanted one language by which the user will be able to communicate with this DB. Means whatever database it was a research project. It was their research project. They developed one database management system, and then they wanted some standardized language using which the user will be able to communicate with that database management. And they came with one concept called SQL. Getting structured query English language. And what was the main intention of that SQL? As if human is talking with another human, very much close to English. As you express anything in English, same way the user will talk with that DBMS. Getting? Like when a human is instructing to someone, some other human in English sentences, very much like that, but it is more in structured way. Getting? More towards mathematical model, not that natural like human languages, but they tried to keep it in that way. That this language is more close towards English like language. As we are talking in English, in the same way, user will talk with the DBMS. DBMS will take that English instructions, interpret that instructions, take the action for it, and give some response back. Correct? But there was some trademark issue of this SQL, and therefore they were supposed to rename it to SQL. They renamed it. And then after that, many standardization organizations came because in market then many other database management system also started coming. Different companies started making their own DBMS. Other companies also. So what was happening? Every company was making their DBMS. So these commands needed some standardization. Otherwise, what was happening? Some DBMS, some commands were not working. In another DBMS, some commands were having some syntactic difference. So some standardization was needed so that the same commands will work for all database. Let the company be anything. Correct. So some committee like NC committee, then NCISO committee was set. Then they created some standardization for SQL. Standardization means you understood, no? They decided the character set, they decided the keywords, then the grammar, what how the command should be for insert, how the command should be for delete. All the standardization was done, and then different DBMS companies were following that standards. Like for web, we have a standard like W3C, right or no? So all the web browsers follow the standardization given by W3C, that is World Wide Web Consortium. Same way here, NCISO committee was set. Then they created some standard keywords, standard grammar, and then all database management companies started following that standardization. Get it? So in market today, whatever database manage, they all follow that standard with little bit changes. Maximum the commands are same. Either you go to Oracle or you go to Postgres or you go to MySQL. Maximum, you can say 97, 98% everything is commands are similar. Correct? So in short, I told you, and please remember SQL come under non-procedural language. Okay, now you'll say what is the basic difference. Languages basically come under two category. One is procedural and another is a non-procedural. All artificial language or programming languages. They come under category procedural, non-procedural, or you can call it as uh, declarative and imperative. Imperative, or you can call it as declarative. Now you'll say what the basic difference is. Whenever we say it is an imperative language, what to do and how to do. What to do and how to do. Both as programmers' responsibility. Means like if you want to do the addition of two numbers, you just don't have to tell, please add these two numbers. How to do that addition is also your task. Algorithms, they are called as algorithm, procedures. Okay? So what to do and how to do, both your job. It is a job of programmer. So C, C++, Java, they come under Python. They are all imperative languages. And declarative language means you just have to tell what to do. You don't bother about how. How is the job of someone else. Like in this case, DBMS will take care of how to insert the record, how to retrieve that record, how to delete the record. All that thing DBMS take care. You are just telling what to do. We are just telling, please delete this record. You are telling, please insert this record. Getting guys? So SQL doesn't come under procedural. SQL is a non-procedural language. In SQL, you just give the command telling what to do. You're not bothered about how. How is the job of DBMS. Getting? But as I said, procedural languages like C, C++, if you take, or Java, there you're not just telling what I want to do. You're writing the program also, no? The whole procedure also you're writing. Someone tells calculate greatest common divisor between two numbers. So the procedure of calculating GCD also you have to tell. It is not on its own going to calculate GCD and give you. How to calculate GCD, that whole algorithm also we have to tell. Get it? So I hope the concept is clear. So difference between procedural and non-procedural. Your understanding, can anyone quickly tell? How do you recognize it is a procedural language? How do we recognize it is a procedural language? Just two things, what to do and how to do, both our job, programmer's job. And how to recognize it's a non-procedural language, non-procedural or declarative, and procedural or imperative. Hmm. Quickly, can anyone tell me the difference between declarative and imperative? Yes, can anyone quickly tell me? No? If you have not
What?
understood, huh? Yes.
Uh, to give instructions, I mean, is only the declarative. How to do the back end other things is the imperative.
I mean, in simple terms, declarative means you are just telling what to do.
Yes, yes, what to do.
You're not bothered about how. How is taken care by someone else. So that is your DBA mistake. Not only in that case, there are many other declarative languages also, like LAYS, Prolog, which are used in AI game development and all. So imperative, what and how, both our job. Algorithm भी हमें ही लिखना है, प्रॉब्लम और प्रॉब्लम का सॉल्यूशन दोनों हमारा काम है. Here only what to do, how the DBMS will take. So SQL always come under which category? Declarative language. Okay, ठीक है? And how this SQL came into existence, I told you, it was a research project of IBM people on this relational database. They had designed their own relational database management, and then they wanted that there should be one standard language which will be very much like English, and the users will talk with that DBMS as if they're talking with some another human. जैसे एक ह्यूमन दूसरे ह्यूमन से बात कर रहा है, that way the user will talk with their DBMS. Get it? It should be very much like instructing in English. And then they came with one language called Structured Query English Language, SQL. But that SQL trademark problem was there. Therefore, they were supposed to rename it to SQL. And then SQL standardization were needed because many more companies started coming with their database management. Many other companies also started developing a relational database. So what was happening? The queries were not becoming same for everyone. There were little bit changes. So the committee was set. Then the committee decided these should be the keywords. This should be the grammar for inserting, for deleting, for creating. And then all the database management system follow that standards, which that NCISO committee created. So it started as a SQL, structured English query language, and later it was renamed to SQL due to trademark issue. Okay, and then as I said, many more things that NC committee was said, then they created a standardization, and then all the RDBMS creating companies. There were many companies who were developing their own relational database. They started following that standards. Okay, and using SQL, what all things we can do? So we can design our database, we can do manipulations on it, like add record, delete record, update record. We can retrieve the information. We can fix the security also on it. Okay, We can do authorization. So many things we can do using SQL. Okay, so please remember SQL is a non-procedural language. Non-procedural meaning using SQL, you will just tell what to do. You're not bothered about how. You will just tell insert this record in this table. You'll say that take these values and please add this record in this table. Now, how the record will be actually added in the table, how the record will be actually added in the table, that will be taken care by DBMS. You're just telling, please give me all the records from employee table. Please give me, like you'll give the command, select star from employee. DBMS will take care of how to retrieve the record, how to give those records back to you. The whole procedure is DBMS job. You're just instructing to it. Okay. So you're just telling what to do. You're not telling how to do. Correct? And using SQL, you can do all the CRUD operations. You can insert the record, you can retrieve record, you can update record, you can delete record, and many more things you can do. Okay, so a lot of things are possible using SQL. So I'll list out what all things we can do using SQL. So SQL allows user to perform variety of tasks. Retrieving the data, you can ask for the information, and while retrieving, you can retrieve on the filtered basis also, not necessarily retrieving everything. Conditional retrieving also can be there. Like you're telling, please give me all the records of employee. Okay, it will give you all. But if you give me all the records of employee, where city equal to Pune, it will filter only those records who are staying in Pune city. Or you're giving condition like salary greater than 50,000. So it will give you only those records. Getting? So you can retrieve in a filtered way. Extracting can be done. Manipulations you can do. Manipulations means adding new record, updating record, deleting record. All that also using SQL you can do. Then you can define the schema, design. You can design your table, meaning you can tell that what should be the name of your table, what all columns should be there in that table, what should be the data type of each column, like roll number, it should be integer, name, it should be varchar, getting percentage, it should be float. So data type, constraints you can tell that roll number should be primary key only. Getting? So all that, like marks, you'll tell it should be between 0 to 100 only. So all the constraints you can put, that is called defining. You can design the table, you can fix the constraints on it. Okay? For faster retrieval, you can create these indexes. Indexes are for retrieving the data fast. And you can control also. Meaning, like you have created the database, you are the user, you are the creator, and you have created your database. But now you want to give the permission of your database to someone else so that someone else also can see your database or can do some changes. So you are granting that permission to someone else, or you're taking that permissions back. That is called taking back means revoking. Giving the permissions means granting. So that thing also you can do using SQL. Getting? So many facilities SQL give. Like you can retrieve data, you can manipulate data, you can define your database, you can control the access on that database. Okay, so all these facilities are provided by SQL. Okay, now till here, if you have any doubt, you can please tell me.
Awesome.
Okay, so we can proceed with the installation, but I think in the next session only, by tomorrow, in the beginning only, we will start with the installation. But before that, just basic information I'll give you, and then tomorrow in the next session, directly we'll start only our session with the installation. Whenever you're dealing with MySQL, remember there are two components. ठीक है. One will be your MySQL server, and both things we have to install. How to do this both installation, every instruction I will do it along with you, don't worry. I'm not just going to give you orally the instructions. Practically I'll show you how to download, how to install. I will also do it along with you. Okay, but before that, just quickly I'll tell you about these two components. One is MySQL server and another is MySQL workbench. Okay, about that quickly I'll tell you, so that then tomorrow no theoretical things, directly we'll start with the installation activity. So whenever you work on MySQL, two components are there. One is your MySQL server. Remember, this is the program which is continuously running in the background. Get it? Means whenever your machines start, this server start. You can stop and keep it. Means you can go to services. You can search from services, just search services. Get it? And you'll get the list of services. And in that, you'll see your MySQL server is running. Now, in my machine, you won't see. In this list, in M category, you'll see. You can stop that service from there. Get it? But by default, it will not stop. By default, what happens is when your machine start, this server also start. So if you want, you can stop and keep it. This MySQL server is a program which is continuously running in the background. MySQL server is a program which is continuously running in the background. And this is only your main database management system. यही वो प्रोग्राम है जो आपके क्वेरीज लेगा, क्वेरीज को कंपाइल करेगा, एग्जीक्यूट, do changes in the backend. Backend means database, and give the response back to the client. Get it? So who is your actual database management system? MySQL server. It is the program which is continuously listening to the client request. And client request will come in the form of a query, SQL query. Client will give in the form of a query. So this MySQL server will take the query, check whether the query is syntactically correct. Yes, it will compile the query, execute the query, do any changes in the storage, produce some result, and give that result back to the client. Getting? So your main database management system is this MySQL server. It is responsible to run your queries. It is responsible to manage your table. It is responsible to provide security. Get it? So that is your MySQL server. And second is your MySQL workbench. This is just the client software. This is the client software. Or you can say this is just the user interface, UI, provided to the client, through which client will connect with this server. Getting? Client will connect with this server and start sending the queries and get the result. Getting? Today only I showed you DBMS runs the query and user is instructing to the DBMS by submitting SQL query. But the main question is how the user is going to submit this query. There should be some interface provided to the user also, na guys? Getting or no? When you book any ticket, any movie ticket or flight ticket, so you go to their website. Na? And is their website a interface provided to you people to pick the movie, then the date, then how many people, and then submit, and then you do this ticket selection and then do the payment. So is some UI provided to you people through which you can do the booking and all? Same way, if the user wants to type the command and user wants to see the result, where the user will be able to see the result, from where the user will be able to type the command. For that, for the user, one software is provided, and that is called as MySQL Workbench. And this is for every DBMS, guys. If you go to Oracle, there will be Oracle server running, and there will be Oracle SQL Plus as a UI. through which Oracle users type the command and see the result. If you go to Postgres, they also give Postgres server and one PSQL software, which acts like a client software. So every database management will give both. They will provide a client UI also and the server also. So server is the main DBMS. It is responsible to take the queries, check the syntax of the query, compile the query, do changes in the tables, produce the result. Getting? But how the client is going to type the query, how the client will be able to see the result. For administration, if the client want to see how many tables, how many databases he has created, how many tables in every database. So for that, for the client, one software is given, that is MySQL Workbench. And always remember, only installing server won't do. You have to install both. Then when you start Workbench, you have to first connect with this server. Once the connection is established, now you can start sending the query and get the result. And whatever result in the Workbench only will show the result to the end user. Understanding what I'm trying to tell you? Okay. So MySQL Workbench is just the client software. It is just the UI provided to the client, through which client can type his query and submit to the server. In this software only the result is collected and shown to the end user. This software acts like an administrative tool. Through this software only we can see how many database we have created, errors you can see, then in every database how many tables are created. All that you can see in this software. Get it? Okay. So the basic difference between MySQL server and the workbench is clear to you guys? Quickly you can tell me to wind up with today's session. Yes or no? I'm waiting for you guys.
Yes, yes, sir.
Yes, sir.
The basic difference you got no, between MySQL server and MySQL workbench. Always remember
Yes.
Is
workbench,
user interface.
workbench will first connect with the server, and then through the workbench we'll be submitting queries, getting the result. Okay. So tomorrow we will go with this. I'll quickly tell you about workbench installation, MySQL server installation, and we'll start doing the work in it. Okay, guys? Okay?